All right, so the way hypothesis testing works, I'll try to draw a nice big bell curve here. All right, so you have these cutoff points. And sometimes it's on one tail or both tails. It just depends on what kind of test. Here we're testing greater than. So we're looking at the upper tail. And when they give you alpha equals 0.05, that's saying anything less than that percent chance is considered unusual or unlikely. So this is the area where the area of alpha is 0.05, or the probability or p-value is 0.05. You also have what they call the critical value, or the test statistic, and that's the z-score that corresponds to that same cutoff point as alpha. So remember how z-scores work. Z-scores start in the middle at 0, and they work their way left and right down to -3 or -4 and up to +3. So small z-scores are in the middle. P-values work the opposite way. So small z-scores refer to the middle, but the middle is large probabilities, large p-values. So a small z-score is referring to the middle, and a large probability is referring to the middle, because there's a large chance of it occurring in the middle of the curve. When you get to the tails, the opposite is true. So these are larger z or t-scores. Same thing here, larger in the negative direction. So by larger, I mean larger in the negative direction. So larger negative, larger positive. P-values get smaller and smaller. The high probabilities are in the middle, the low probabilities are in the tails. So the larger the z-score, the lower the p-value or the probability. Same thing here, larger z-score, lower probability or lower p-value. Alright, so the question is asking, choose the correct result of the hypothesis test for the classical approach. So it says reject the null because the test statistic is less than the critical value, or reject the null because the test statistic is greater than the critical value. And then it says do not reject the null because the test statistic is greater than the critical value, or do not reject the null because it's less than the critical value. So there's only two correct options here. We would reject the null because the test statistic is greater than the critical value. That's one possible option. So option A does not make sense. You don't reject if the test statistic is less. And the other option is do not reject if the test statistic is less than the critical value. So those are your two valid options. A and C don't work. Then you're going to go in the calculator and you're going to run this test. Oh, I'm sorry, alpha was 0.01 instead of 0.05. Sorry, change that to 0.01, whatever the alpha is. So go ahead and run this test. Go to Stat, Test, and then you're going to choose the 1 proportion z test. And you're going to get a z-score or z-naught. Whatever that number is, you're going to compare that to what they call the critical value. The critical value comes from the chart that you'll see attached to this question. So you're going to compare those two, and if the z-score is smaller than the critical value, you fail to reject. So in the middle, you fail to reject. If the if the z-score is larger, the test statistic is larger than the critical value, then you reject. So you reject when it's in the tails, and you fail to reject when it's in the middle. Alright, so same idea with the p-value, but it's in the opposite relationship. So for the p-value, smaller p-value is reject, larger p-value is fail to reject. So for the correct answer for part B, reject the null if the p-value is greater, that's not a valid conclusion. Do not reject because it's smaller, that's not a valid conclusion. So you either do not reject if it's greater, meaning it's in the middle, or you reject if it's less than alpha. So when you run that same test, you don't have to run it again, you're going to get the p-value. You're going to compare that number to alpha, which in this case was 0.01. If the p-value is smaller, you reject. If the p-value is larger, you fail to reject.